Now in this lesson we're doing work on the parabola, vertex, focus and directrix. Okay, a big title. Now the basic parabola x squared equals 4ay. Now if we just consider the axes there, it will go through the origin. Okay, that's its vertex. So that point there, the vertex 0, 0. Now the a is known as the focal length. So that distance from the vertex, if we go up a distance a, we get to a point which is called the focus. Alright, S 0a. S for focus for some reason, but the coordinates 0a. The other thing, if we go down from the vertex, okay, again a distance of a, we come across a line, and that line would be y equals minus a, and that is known as the directrix. Now by definition of the parabola, PS equals PM. Okay, so P is a point on the parabola. The distance from the focus, PS, equals the distance to the directrix. Alright, so that's the definition of a parabola. Those two distances are equal. Now let's see some examples. The first one, draw a neat sketch of the parabola x squared equals 8y, clearly showing the focus, vertex and directrix. Now with all of these questions, even if they don't ask us to draw a sketch, we will do so because it helps us with the work later on. So there's our equation there. Now it's of the form x squared equals 4ay. So let's just concentrate on that. We need to write x squared equals 4 something y. So that 4 something, okay, 4a needs to be 8. So we need to put a 2 there. 4 times 2 obviously is 8. So that 2 is our value of a. Okay, known as the focal length. So let's draw a little sketch. Its vertex is at the origin. Now a equals 2, the focal length. Now if it's positive, alright, if it's a positive focal length, okay, it's a concave up. We've already drawn that. But we go up 2, and that will be the focus. Alright, so that'll be the point 0, 2. And from the vertex going down 2, okay, that point there, we draw a line through it, a horizontal line. It has equation y equals minus 2. So there's our formula there. Always a good idea to write the equation on the graph as well. Excellent. The second example, we need to draw a neat sketch of the parabola x squared equals minus 2y. Again, clearly showing the focus, vertex and directrix. So let's write this down. Again, it's of the form x squared equals 4ay. So let's concentrate on that. We need to write x squared equals 4 times something y. Now that 4 times something, we need to get minus 2. So this time it'll be certainly a negative and it'll be a fraction. It'll be minus a half. So therefore a equals minus a half. And as soon as a is negative, you'll find that it's concave down. Alright, upside down graph. So it's an upside down graph. It again is going through the origin, that's its vertex. Now a is minus a half. Don't worry about the minus now, we'll just think of half. Let's go down 1/2, and that will be the focus. The focus is always on the inside of the parabola. Alright, just remember that. The focus is inside the parabola. And if we go up 1/2, that line there will be y equals 1/2. So that's the directrix there. Okay, and as before, let's just write down the equation on the graph as well. Terrific. Now, this type, x minus p in brackets squared equals 4a, y minus q. Well, this time it's a parabola, but the vertex is not through the origin there. So the vertex is at the point PQ, and the a is the focal length as before. Alright, now in terms of finding the directrix and the focus, we'll do that from the graph. Okay, it's essential that we draw a graph in this case. So there's our information. Okay, and just note too, the minus p, the minus q matches with PQ. So it's a little bit with the circle, very much like the circle when it's not having its center at the origin. Alright, we actually do the opposite. Minus p minus q, the vertex PQ. Now let's look at some examples of this type of parabola. We need to draw a neat sketch of the parabola given. X minus 2 squared equals 16 times y plus 3. and again, focus, vertex, directrix. Okay, we're interested in those three things. So let's just write down the equation there. It's of that type. So x minus 2 squared equals, now the 16, we need to replace that 16 with 4 times something. Okay, the y plus 3 remains in brackets. So 4 times something makes 16. Well, it's going to be 4. So 4 times 4. So that value there is a. A equals 4. Now, so let's draw a sketch there. Now, minus 2 and 3. Now, we do the opposites. We're thinking 2 minus 3. That'll be our vertex. Now, it's positive. A is positive, so it's going to be concave up. And our axis of symmetry is very important to help us work out where the focus would be. Now, A equals 4, which means we go directly up 4 from the vertex. So that will be the focus. Now, have a bit of a think. You've gone up 4. It will be 2, 1. All right, the x coordinate still be 2, but in terms of y, we've gone from minus 3 up 4. That's why we're getting 1. We go down 4 as well. And so in terms of y, at the vertex is minus 3, we're going down 4. That would be minus 7. Okay, and the equation of the directrix y equals minus 7. Okay, last step, let's just write down the equation on the graph. The next one, we need to find the focus and directrix for the parabola. 2y equals x squared minus 4x plus 6. And again, draw a neat sketch of the curve. Now let's just write down the equation we've got. Now again, it's of this form, x minus p squared equals 4ay minus q. But if we have a look at it, x squared minus 4x, we'll need to do what's called completing the square, okay? But what we'll do firstly, we'll just write the x squared, etc. on the left-hand side equals 2i. Just swap the signs. Now, use the method of completing the square. What that means, x squared minus 4x. We're going to write that down. Then with the positive 6, we move that over, becomes minus 6. So we'll have 2i minus 6. Now, I deliberately left a little bit of a space there because we need to use the completing the square method. Now, what that means is this. We need to write that as a square, perfect square, x and then something in brackets squared. Now, to work out that something, the minus 4 with x, we halve it. So we get minus 2. And minus 2, once we square it, is positive 4. So really, before we could write that brackets, we really need the plus 4 up there. Okay? And if we add 4 to the left, we must add 4 to the right as well. So on that right-hand side, if we tidy that up, we get 2y minus 2. So on the left-hand side, we're going to rewrite the x minus 2 squared. Now the 2y minus 2, we need to factorize it because we need the y singular in brackets. So 2 goes out, and in brackets y minus 1. So we've got that singular y in the brackets there. Again, just rewriting the left-hand side. Now the right-hand side, we need it of the form 4a, and then in brackets y minus q. So we need 4 times something. Okay, the brackets remain the same, but 4 times something makes 2. Well, that something would be 1/2. So there we have it. A equals 1/2. That's our focal length. Now the focus and the directrix. Well, firstly, we'll draw the sketch of the curve. Okay, so even though, the question asks for the focus and directrix first, the sketch of the curve is the most important thing to help you find everything. So what have we got? The minus 2 and the minus 1. Remember, with the vertex, we do opposites, so it's going to be the vertex will be 2, 1. Again, the axis of symmetry. Now, the focal length is 1/2. It's positive, which means it's concave up. And we go up 1/2, and that focus will be at the point 2, 1.5. From the vertex, if we go down 1/2, alright, that will be a y value of 1/2. That will be the directrix, y equals 1/2. Again, last step, let's just write down the equation on the graph. Excellent. Now, find the focus. We better write down the answer. The focus there from the graph, obviously, 2, 1.5, and the directrix, y equals 1/2. Our third example here, we need in part A to sketch the parabola which has focus 1, minus 3 and directrix y equals 1. And part B, find the equation of the parabola. Now let's just draw the sketch firstly. Now the focus, 1, minus 3. Let's write that in. The axis of symmetry is going to be important. Now the directrix y equals 1. Okay, that means it's cutting the y-axis at 1, and it's obviously a horizontal line. So there we have it, y equals 1. Now, let's just consider our y-coordinates there, minus 3. Let's mark it in on the y-axis. So we can see clearly then that the distance between the focus and the line, the directrix line, is 4 units. So the vertex is exactly halfway between the focus and the directrix. So the vertex there will be up 2, which would mean it would have coordinates, think about it, 1, minus 3. We're going up 2, it would be 1, minus 1. Alright, now, the focus is always inside the parabola. So you can see that's why we've drawn the parabola the way we have. If we drew the parabola the other way, it would actually cut through the directrix. That will never happen. So we're up to finding the equation of the parabola. So it's of that type certainly, okay, because the vertex is not at the origin. Now we say x minus p squared, where we do the opposite. Alright, so we're going to be writing x minus 1 squared equals 4a, where a was 2, but because it's an upside down parabola, 4 times minus 2. And then finally y minus q. Okay, so again doing the opposite, we'd have y plus 1. Okay, that just tidies up. X minus 1 squared, 4 times minus 2 is minus 8. And then we just rewrite y plus 1 in the brackets. And that's it. Okay, so that is the equation of the parabola. And we'll mark it in on the diagram.